Hello everyone and welcome to all of you to our channel Schrödinger's Cat, and this is basically Devabrata here. In our previous lecture we had discussed the electromagnetic waves and communication system and today it is our last lecture number 18, that the practical physics. And in this part today we will cover that the experiments related to the units and the measurements, oscillations and waves, properties of solids and liquids, current, electricity, optics and electronic devices, and the total number of questions are coming in the entrance in NEET exam. 2 questions, JEE main 2 or 3, and the advance 1 or 2 questions are coming in this chapter. So you see a practical physics, and total in our NEET, JEE main and advanced physics there are total 18 units. So first one in class 11, units dimension and error, kinematics, laws of motion, work energy power, rotational motion, gravitation, properties of matter, heat and thermodynamics, oscillation and waves. And class 12 electrostatics, current, electricity, magnetism, electromagnetic induction and alternating current, optics, modern physics, solids and semiconductor devices, EM wave and communication system and the particle. And last one the practical physics. So we just cover here the total JEE main and advanced and NEET physics. This is our last lecture, and I just confess one thing, for your exam point of view today we will discuss the chapter summary in a nutshell and do the problem coming in previous year NEET, JEE main and advanced, and after we just theory elaborately and practice previous year question papers. Let's get started. First of all, that I usually draw 2 section of board and just go ahead. So in practical physics, first one the Vernier calipers. So in Vernier calipers, the Vernier constant, that the VC or the least count LC, that is equal to the smallest mean scale division, smallest MSD mean scale division, divided by total number of division in Vernier scale, Next one, the total reading, the art total is main scale reading plus number of Vernier division coinciding, that the number of Vernier division coinciding into Vernier constant, and positive zero error, that the positive zero error that is equal to the number of Vernier division coinciding in the main scale. I just short write number of Vernier division coincide in main scale into Vernier constant. This is multiplied by Vernier constant. Next one, the negative zero error, that is number of Vernier division coinciding with main scale, this would be the same, into Vernier constant minus smallest minus smallest main scale unit. Next one, the corrected reading. So these are our last reading. The corrected reading we just take in our practical lab, that the observed reading minus 0 with proper sign. 0 with proper sign. Next one, the least count of screw gauge. The least count of screw gauge, that is equal to the pitch divided by total number of division on circular scale. And next one, that the Y Young modulus stress divided by strain, and it is written at that mgl divided by pi r square l, mg capital L by pi r square small l. Next one, that surface tension of liquid capillary raise method for water where cos alpha nearly equals to 1, that S is equal to RH plus R by 3 rho z divided by 2 cos alpha. Next, the time period of the pendulum t equal to twice pi root over displacement by acceleration. And next one, the principle of calorimetry. That states that heat loss is equal to heat gain. Next one, that the Laplace correction in closed pipe, Laplace correction, that E equal to 0.6 R. This is for the closed pipe. And next one, twice E equal to 1.2 R. This is for open pipe. We just deduce in your wave chapter. And next one, hence the velocity would become that n v divided by, with the denominator, L plus 1.5 R. This is for the open pipe. And the v would be n v by 4 L means correction, L plus 0.6 R. This would be the closed pipe organ. Next one, that mu is the frequency of the trunking fork, then v equal to nu lambda, that is twice nu del L, L2 minus L1. Next one, for a meter bridge, at the null point, the unknown resistance X would be R divided by L, 100 minus L. This is the unknown resistance. Next one, at the potentiometer, that comparison of EMF of two cell, that the epsilon 1 by epsilon 2, comparison of two cell, that is equal to L1 by L2. And here the internal resistance R would become epsilon minus V by V into R. Next, figure of merit is defined as the current required to produce unit deflection of the galvanometer, that the G is equal to I by theta is equal to K by NAB, that is equal to Z. This is the galvanometer constant, and the last one, this is the galvanometer constant, and the last one, the prism formula, the refractive index mu is equal to sine A plus delta m by 2 by sine A by 2. This is called the prism formula. This is called the prism formula. So we just discuss here the chapter summary of practical physics. Now switched our lecture in problem discussion session. First one is coming in NEET 2024 recent type questions, that says in a Vernier calipers n plus 1 divisions of Vernier scale coincide with n division of Snell scale. If 1 MSD represent 0.1 millimeter, then what would be the Vernier constant? You have to find the Vernier constant Vc. So here that 1 MSD we just discussed in our chapter summary, this 1 millimeter. So n plus 1 VSD would be n MSD. That 1 VSD, that n divided by n plus 1 MSD, n scale division. So least count or Vernier constant would become that the 1 MSD minus 1 VSD. Just put this value 1 minus n divided by n plus 1. This is MSD. So it would become that the 1 by n plus 1 MSD. So 1 by, so this is equal to 0.1 divided by n plus 1 millimeter. Just convert in centimeter, 1 by 100 into n plus 1 semi. So our answer would be the B. In centimeter, 1 by 100 into n plus 1. Go ahead. Next one is coming JEE Advanced 2014. During an experiment with a meter bridge, the galvanometer shows a null point when the jockey is present at 40 semi. Using a standard resistance of 90 ohm as shown in the figure, the least count of the scale used is 1 millimeter. So you have to find the unknown resistance. I just discussed in the chapter section this problem. So you have to find the unknown resistance, that X. So unknown resistance you have to find, so that meter bridge in balanced form, that R1 by X equal to R2 divided by 100 minus X. This is condition, and here R1 is R, R2 is 90 ohm, and the X is 40 semi given. So put this value, R by 40 is equal to 90 divided by 100 minus 40, that would become 90 by 60. So R 60 ohm. So this is equation number 1. So here that you just calculate. So differentiating with equation 1, that ln R1 is equal to ln R2 plus ln X minus ln 100 minus X. Next one, the ln R, that is equal to ln x minus ln 100 minus x plus ln 90. Just calculate, and here we just not differentiate, here we just take the log both side of equation 1. Now differentiating both side. So now differentiate both side, that del r by r is equal to del x by x minus del 100 minus x by 100 minus x, that differentiate both sides. So that del r by r is equal to del x by x, del x divided by 100 minus x. So error in is positive only, so you have to take the mod value. So del r would become, just put this value 0.1 divided by 40 plus 0.1 divided by 60 into 60. So it would become 0.25 ohm. So R would become that 60 plus 60, here in this calculation you just get here the 60 ohm. So 60 plus 0.25, 60 plus 0.25 ohm, plus or minus, C would be our correct answer. Unknown resistance would be 60 plus minus 0.25 ohm. Go ahead, our next problem, that's the JEE NEET 2015. The time period of oscillation of a simple harmonic pendulum is given t equal to twice by root over L by G. Measured value of L is 20 semi, known to 1 millimeter accuracy, and time for 100 oscillation of the pendulum found 90 seconds. Watch of 1's revolution. The accuracy in the determining of G. Accuracy in the determining of G in the percentage means you have to find the del Z divided by Z into 100%. You have to find this. So you just know this formula, t equal to twice by root over L by Z. So here Z would become that the 4 pi square L divided by T square, and T be the T by N, just put this value. So 4 pi square L N square divided by T square. Now that you have to find the del Z divided by Z into 100. That would be del L by L into 100 plus 2 del T divided by T into 100, because here the Z is proportional to that the L by T square. So Z is equal to KL divided by T square. Now here just take ln. Ln Z is equal to ln K plus ln L minus 2 ln T. And for your accuracy you have to the mod. Mod means this one would be the positive. So now differentiate both sides. So you have to differentiate that the dz by z is equal to, this would be the constant, and here the dl by l plus 2 dt by t. I just write here in this condition and just put this value. So 0.1 divided by 20 into 100 plus 2 into this one is 1 by 90 into 100. So it would become 2.72%. After calculate, nearly equal to 3%. So D would be our correct answer, 3. Switched into our next problem, that the JEE NEET 2015 saying that the AC voltage across a resistance can be measured using, what option would be correct? And we just know the P average that the Vrms square divided by R. So Vrms square would be R into P average. So D would be our correct answer. Vrms square equal to R into P average means the hot wire voltmeter. Next one, that's coming in JEE NEET 2017, saying that the following observation were taken for determining surface tension T of a water by capillary method, given D and H and G, and you have to simplify this relation T equal to RGH by 2 into 10 to the power 3 meter per Newton per meter. The possible error in the surface tension would be what? So possible error in the surface tension mean you have to find the del T by T into 100. Same as the next previous problem. So here given equation T R H Z divided by 2 into 10 to the power 3 Newton per meter. So here R means D by 2. So it would be D H G by 4 into 10 to the power 4. No problem. So you have to find del T by T into 100. So it would become that the del D by D into 100 plus del H by H into 100. Just put this value, that 0.01 into 10 to the power minus 2 divided by 1.25 into 10 to the power minus 2 plus put this value 0.01 into 10 to the power minus 2. I just convert in your same SI unit. So 1.45 into 10 to the power minus 2, this is into 100 for percentage. So it would become the 100 by 125 plus 100 divided by 145. So it would become 0.8 plus 0.689. So it would become 1.489%, that nearly equals to 1.5%. So B would be our correct answer, 1.5%. And for this problem, we just do here the earlier problem. You have to keep in mind this concept, that suppose T equal to twice pi root over L by Z. So first of all, the Z would be 4 pi square L by T square. We just do in a previous problem, that this one. So just T equal to T by N, that the 4 pi square L N square T square. So I just say one thing, that you just consider the equation number 1. This is the equation number 1. So first one, taking, that is taking ln both side. This is 1. Next one, differentiating both side. These two are main fundamental. Suppose given the x is a to the power m, b to the power n by y. So you have to find the ln both side. So ln x would be m ln a plus n ln b. You have to choose the minus ln y. So in your error correction, you have to choose the mod value. The mod value means this is plus ln y. Now derivative, d of ln x, that 1 by x. So and the dx for the differential. So this is written as the dx divided by x. Basically here it is written as the ln x differentiation 1 by x and the x differential dx. So this would be m dA by a, this would be n dB by b, this would be the y, this would be the dy by y, and here the dx by x is equal to del x by x. This is the main concept. So we just cover here 5 important problems, and I usually give you for your better clarification and the conceptual problem 5 another. Just take a screenshot pausing the video. So I think you just take a screenshot of this problem. So we just now cover here the 10 important problem coming in NEET, JEE Main and Advanced with the practical physics. These would be our last lecture, lecture number 18, and after that we just discuss the previous year question coming in NEET, JEE Main and Advanced. Basically would be the problem discussion session, fully problem, and here we just now do theory elaborately. Basically we just go through in your textbook. So here for the exam point of view, we just discuss the problems coming in previous year with recent type of questions, JEE Main, NEET and Advanced. So last one, you just solve this homework all and mail without no hesitation cat Schrödinger's 1935@gmail.com. This you do have also in our YouTube lecture description box. So basically we just cover here all the topics of NEET, JEE Main and Advanced. You just follow in my channel that the Schrödinger's cat, the URL @Schrödinger's cat 1935. So we just see you after some day with your problem session. And last but not the least, if anyone need my YouTube lecture file, just mail without no hesitation. And thank you very much. Stay well and happy. Have a good day.